Okay, now that we have done the steady simulation on steady simulations, interpolating the solution, starting the solution from a steady one, getting good at the initial conditions, saving frequencies, choosing time steps, and some post-processing in Paraview, let's move to another subject that will complement somehow what we have done before. This is before not moving to the list, which is mesh refinement, okay, within Fluent. As I told you before, it is better to do it in at the mesh level, okay, so you have the geometry and the mesh, better do it, but I will show you how to do it here in Fluent, and we are going to do some also some post-processing just to compare solutions in Paraview. So these first things that I want to show you, that we saw how to save automatically the solution to inside format, but you can also save one specific format. So here I have the coarse mesh, I have the final solution, this is for 20 seconds. And if you want to save the solution, this specific time step, you go here, export solution data, choose your format, and then choose what you want to say. So I will save this L0RL and just pressure velocity. You press right, you give it a name. So we call it new, and it will save all the data on the mesh. This is just one single time step, okay? So later we're going to post-process using Paraview. What I wanted to show you here was that okay, let's visualize first the solution. Okay, so if I go results, okay, so this is the velocity field, this is at time 20 seconds, okay, fully and steady, and if I will recall, it was a CFL of 5, and we have access here, so you can access, for instance, we have a steady statistic. So you have the mean pressure, look at, also we have access to RMSE, okay, root mean square, so this is standard deviation minus the mean value, okay, so we have the fluctuations, actually, these are actually the fluctuations, and if I put in, so we have the fluctuations, and set also we have our values there. So your statistics, okay, so you just want what else? Again, turbulence, you can access all your variables, y plus, everything. And what we want to see now is custom field L0. So look at that, L0 here depends for it is for a specific time, not for this specific time step. So it is recommended when you do this one also to compute the statistic of this one and get the statistic. So usually the statistic in this case, you will have this weight that it will move and probably will give you a cone here, a triangular, and then when you do the meshing, you will put it there. In this case, I didn't compute it, but remember to compute it is highly recommended. And then if we put RL, this is the one that will give a refinement ratio, auto range, and see that everything above 5 will be in, that is what resolves. So here in the far wake, it's telling you that kind of is resolving well, but here is missing something. So maybe we can add some refinement here. But also, let me go and report and let me compute surface integral, the average value, face average of what turbulence, and let me go y plus here. So see that our average value, okay, that was the maximum, sorry, it's about 19. So probably might be better also to add some refinement in the mesh, okay, to go to 10. Okay, remember it's better to do it at the mesh, using the meshing utility, but as you want to do it here, it is possible. So let's do it first to add two refinement conditions, one for y plus or close to the wall, and the other here in the wake. Something also interesting to show you that I can create an isosurface in the domain, and I will use RL, and I will put 5. Okay, so this will give me kind of the boundary. So let's see if I have, yeah, they have it there. So if I plot here, it will give me the boundary of the region. So everything outside this, see that it is the where I should put more grid points to better resolve those scales. Remember that on a steady solution, this will change from time step to time step. Okay, so that we have this. Let's go here and self-register. Also, you can access that here. I have it here, results, and okay, give me a minute. Domain here, adaptation. You have also those options there. But I will go here. I will tag cells. So the self refinements that I would like to do, see that you have the option y plus y star. So I will choose only in the square, okay? And I will go compute, I told you. So basically choose values here, and everything outside these values will be tagged for refinement. Okay, so save display, see that these cells will automatically tag for refinement. Okay, so for instance, you will see that if I put here 1, didn't have anything. Okay, so they're contained, so they're not refined. Okay, so this is how you will play with this. So you can add this one, and what Fluent will do is will split these cells. Okay, so now you have that group. Okay, so register. Let me create. So as you go, you select new, refine, and see that it will be automatically refined, just those cells. Okay, so see original, adapted. So if we go back to mesh, in this case, and as you zoom in, see that the cells were split, and even here in this direction. Okay, so it's the sense that it's practical because you need to go back to the mesh, but it's not ideal. You know that probably this refinement will be really easy to do in the mesh utility. Let's add another refinement type. Okay, so I can go new from boundary, and then I can say from this one, you can choose here cell distance, normal distance. So I would say cell distance, and I want to say the next 2 cells from that wall, and see that it's choosing the next 2 cells, including that corner that previously it wasn't chosen. So I put 3, see that the next 3 cells are chosen. So let me tag this. Okay, this is the one that I will use, and then go boundary, and I want to refine just those cells. Okay, if I go now here, draw mesh, and this, just to put a color there. Okay, and I don't want to see this. See what we have. Now this was refinement, and now surely this one will be my y plus average. Previously was about 19, now this will be below 10, I'm quite sure. Okay, in all that direction. So this is one way to do the refinement within Fluent. So the other one that I would like to add is here. I want to say where my RL is between, let's say 2 and 3. Let me switch it. So between, let's say, yeah, 2 and 3 and 2 and 5, add more refinement. Okay, so how to do that one is something very similar. You go back here, new, and you go, there are many options. I will use the field variable. I would say cells in range. You choose your variable, it will be RL, and you put there 2.5. You have many options now if you want to use gradients, whatever, but for me, just give that one. Save display, give you a warning that there are too many cells. It might slow down things, but it doesn't matter here. I will show you. And see that it's tagging cells. So here you see that you have some noise there that is trying to refine as well. And you have that group there. And again, you can go here, field boundary, and you can say refine that. So if you do this one, this will be expensive, it will be heavy, it will put a lot of cells there. I won't do it. I just will use only the one for the boundary layer. And let's run a couple of time steps just to see what happened now with my solution, okay, with my y plus value. So I will need to compute it here. Let me go here and let me change this definition that was maximum. Let me put it average. Okay, just to date it. And what else? Nothing else. Okay, so see that now that I have a much finer mesh, I will need a smaller time step. So previously for this, the time step was about 2 now that I recall, I think. So now it would be larger. Okay, I need to change the time because here that's flow time. Let me put 13 and calculate. So as usual, there will be a jump in your residuals. Okay, and then we have the monitors. So my y plus, remember this is average. It's about 6, okay, so this is okay. So we went from 19 to 6 by just adding 3 levels. And see my CFL number, it went high, okay, increased. So previously, yeah, but from this time, times it was about 1.5, something like that. So adding that refinement increase that one. So this requires that I will need to reduce my time step. So see that this is also the problem with refinement, or not the problem, is just a consequence of what you are doing. So as you make it fine, it's clearly that you will need to reduce your time step to get your CFL number within the values that you are interested. So let me stop here, and then this will require quite aggressive time reduction. So see that I will need to go 0.0005 to probably get something about 1 or 2. Okay, I need to check this one. Okay, yes, about 1.2. Okay, so this will be my time step. So see that it's converging in about 3 iterations. Ideal, actually 2 iterations. That is ideal. But you make now the math that, see, previously using 10 to the minus 3, it was taking, let's say, 2 days. This one that you are halving will go 4 days. Just, and see that the increment in number of cells wasn't that much. It's just reducing the distance, the y plus value related to y plus. So see, sometimes also you have to be careful in non-steady, because ideally we would like to go always wall resolving, but on unsteady that will have a price. So again, will be a compromise for use. Okay, using wall functions, use wall functions on a steady. On the other side, you are doing steady simulations, my advice is always go for wall resolving. Then you can interpolate a wall resolving into a wall modeling mesh with no problem. We have done that. Okay, so if I stop here, we got the idea. Probably let's see what we have. Is we already have something here. Okay, well. Okay, so this was for this one. Is let me open now. I also have this was the quartz mesh, by the way. So just take a picture, a mental picture of this. And let's go to define mesh and let's see what we have there. So by the way, in the cases that you have in the files, in the interpolation files, in here, the urls, this file, interpolation file, corresponds to this solution, to 20 seconds. The same will be here in fine. So this will be less 20 seconds, runs, okay, this is the runs, I think, I don't recall if it is coupled or simple, but it is a run solution. But here, less, all the unsteady correspond to 20 seconds. So here you can use the runs 20 seconds and interpolate it into your fine mesh. Okay, so we have that. So here the mesh is the same, even the wall distance will be the same. The only thing that we have more cells in the spans y direction. So if I show this, okay, so a little bit different. Okay, we have finer mesh and we'll resolve different stuff. And already see that my maximum is higher. Okay, so this one is probably giving me better resolution. And I actually see that this one is resolving all the way much better. Okay. But again, you can use the same criteria and add some refinement, but those refinement that you add will be local. So just to show you, for instance, in this case, and if I go self-register, new, and let me do field variable, and I want source and branch, I want custom field function, and I want, okay, yes, okay, so let me go better 3 to 5. Okay, so see that if I pick up those cells, I do like this, refine, it will take a while. Okay, we'll add a lot of cells. So see that probably it will be adding this many cells. Okay, you see from almost 500,000 it went to almost 1,000,000, almost double your mesh count. Let me plot. Okay, let me plot this plan. Okay. Why? So let me put a velocity field probably there. Okay, I think now it's easier to be. So see that this will be a remesh, but it's local. Okay, so and then when my solution evolve, now you are not resolving those scales as it should be. Okay. Okay, so this is how to do the refinement here. Okay, so this will be an extra step, but again, better do it in your meshing tool. And from here, as I mentioned, that compute also your statistic for RL and see where you will have. So here, as you compute those statistics, you will see that it will be kind of a calm region here, and then you will know that you will need to add more cells here. But in general, this mesh is already a good one to do the less we have seen here. Okay, that will be the next step. So before doing that, let's do also the post-processing using Paraview, okay, because I saved those two solutions and comparing Paraview just to, again, reinforce the use of this tool. So remember to use your GPU card when open Paraview. Okay, inside Paraview, let's open the two cases. Okay, so we save the quartz mesh, so I have it here. So remember, when you open, select all files, open the encast file, and select inside reader. Okay, so we'll give you this. This is a warning, don't pay attention to this. I will check what is that, but that's not, I think it's not a problem. So this is the quartz mesh. Okay, so you can check with edges there. So, and then we're going to compare. So we have RL as well. Let me change the background. And let me create a second window. Now I will plot in that window the second one, white as well. So here, see the blue frame means that this is the active window, and I'm not visualizing that case there. And now I select the second case with which will be all files, and this one I think, and site reader. Okay, don't pay attention there. Again, yes, we have this one. Okay, this will be the second case. Okay, this is the refined mesh, and see that we have the adaptation in this one. So now let me link with this right click, link camera, so click there, and now there are both link. Okay, so you want to unlink, here you have manage links. Okay, so here you see the quartz, and this one only see the refined mesh. I don't want to see the scales. Okay, so what I want to do is create a cog plane here, and the same cog plane there. Okay. Oops. Okay, no, this one. No. Okay, so that here, cog plane, apply. Okay, so I don't want, okay, leave it like that. Okay, so see quartz and fine mesh, and see that we have the resolution are different, but we are interested in looking at RL and RL. Okay, so see that we have different fields. So in this case, you have this one because remember that we added the refinement, and I think I didn't run, so we have this. Okay, let's see that they are very different. Okay, so this one get it resolved better. So here, much better resolution. Okay, so we can compare LCU as well. And surface with edges, and you can see the edges just it's automatically triangulated. So deselect that one, no triangulation. Probably you see those lines, it's just the projection of the shapes of the cells. Okay, it's not a big deal. Okay, so see here that we have the refinement. Okay, but as I didn't run a couple of times, so we have the interpolation there that is missing a little bit. Okay, see there. Those holes also you see, so that refinement is not a big deal again. So see that again here, you can compute all these quantities here. Okay, here is, okay, I was looking at 0 previously, there RL. Okay, now click on, no. And this one, let me put also RL. Okay, clearly, well, see here, RL values are larger, so this one have better resolution of your structures. You go velocity magnitude also, and again, as you want here, you see here that we don't have the Q criterion from OpenFont. As you want, you can compute it, so you can go here, filters, and you have gradient. So remember that it's based on velocity. See here, compute criterion, enable that quantity. It takes a while, so you can guess this is just one time step. If you have many time steps, it will compute it for every single time step. And then we can go here, Q criterion, 100 probably will be a little bit messy, or will be nice because we have the refinement. Okay. Okay, so that this is what we have there. And if I plug in the cut plane, and let me change that color. No, it's just want this color. Okay. So yeah, some of the refinements are just entering there, capturing that one. But remember, it was a different refinement for that we're using there, so it does not correspond to the Q criterion. Again, you can add a refinement in the Q criterion, and you can refine result much better, and it can be adaptive. So each time it would refine. That is really expensive, by the way, but it can be done with no problem. So quartz mesh, fine mesh, with the adaptive mesh refinement, and we compare the scales that clearly are different. So I think this is all for this tutorial. The next we move into less test simulation, scale resolving simulations. Okay, well, thank you for your attention and hope you enjoy. Bye.